Hey guys, Buildzoid here, and I'm super behind on getting stuff done, as always. This Kingbank memory kit showed up 2 weeks ago, so today we're going to be taking it for a bit of a spin, because, yeah, I'm starting to feel bad about, not having done anything with it. But the thing is, I'm kind of more interested in messing with the RX 9070 than stress testing RAM, so this is my alternative to that. So we're just gonna so we're not gonna be running any stress tests. We're just gonna kind of get a feel for the memory kit today. Um, anyway, yeah. So big thank you to Kingbank for sending over this memory kit at my request because I did want to test or like do want to test more 2x48 gig setups because I only have one other 2x48 gig kit. So yeah, I just want to like more variety, more better as far as memory kits goes, in my opinion. Um, and the CPU is a Ryzen 7 9700X, which I usually use. Well, I primarily use the CPU for 2-to-1 mode testing, so I'm not entirely certain how it's going to behave in 1-to-1 mode, which is what we're going to be doing today because this is 2x48 gigs, and I don't really expect 2-to-1 mode to get very far. Though I guess we can start with that because when I turn on Expo, it's going to default to 2-to-1 mode. Anyway, yeah, the memory kit is of course Hynix 24 uses Hynix 24 gigabit MDI memory chips in a dual rank configuration. And the motherboard I'm using is a Gigabyte X870 Aorus Elite Ice, which I bought, so a big thank you to the channel supporters for funding the purchase of the motherboard. And with that out of the way, let's get into it. Oh, and I do have a fan on the memory because, especially with dual rank DDR5, I would very, very strongly recommend a fan if you're going to be overclocking it because it runs hot. So, yeah. And also, this is RGB, so that makes it even hotter. So, anyway, let's get into it. As you can see, I have wiped the BIOS, so we're going to be starting from literally zero. Well, okay, I was a bit worried there that it was about to do something that I wasn't expecting, and I have not used a Gigabyte board in a while, so I forgot the shortcut. For getting into advanced mode, it's F2, and we're just going to start with turning on Expo, which is 6400 CL32. So this will probably default to 2-to-1 mode, which we will do like a baseline test of the performance. I expect it to be kind of horrible. We are not going to run IDA because like the IDA's memory latency test is bad and people should stop using it. So yeah, that's why like you don't see me like I used to use IDA, and then over time I've come to the conclusion that it's honestly kind of horrible for testing memory performance. And especially with Ryzen CPUs, it's like extra bad because there's basically like most motherboard BIOSes now have an option to basically turn off a bunch of like memory management optimizations in the CPU, which boosts IDA latency performance at the cost of literally everything else. Because there's like a slight amount of overhead to the the memory optimizations that the CPU has built in. Um, and so if you have very low intensity memory workloads, which is what the IDA latency test is, then it kind of like the overhead outweighs the benefits. But if you have any kind of actually memory intensive workload, like a video game, yeah, turning off the memory optimizations that the Ryzen CPUs come with is a bad idea. So anyway, here we are. I do have Zen timings installed, so that's good. And 1.2 volts SoC, 6400. Yeah, we're in 2-to-1 mode. UCLK is at 1600. So for benchmarks, we're going to go with 3D Mark. We'll use Time Spy because that one's more popular. Technically, 3D Mark's 11 physics test is also a very good memory test. I'd say arguably better than Time Spy's CPU test, but both of them are pretty good. So if we run Time Spy, so yeah, because this is actually like surprisingly memory intensive. So anyway, we'll just run that. The thing I don't like with, well, actually, even the 3D Mark 11 test is kind of inconsistent, but that's basically any memory test in my experience, is that they're all kind of inconsistent. So, yeah, because the moment you have something that's very sensitive to memory performance, it's also so sensitive that it tends to not be super consistent. It also, I guess, doesn't help that, like, well, you get, like, memory tests that are, like, short, or you get memory tests that are annoyingly long. And if they're annoyingly long, they tend to be less inconsistent, but then, you know, they're annoying to run because they're long. Anyway, I should probably be noting down scores. So yeah, we get a horrible just under 14,000 points. Oh, we're on a completely... actually, you know what? I won't, like, PBO the CPU. This is one annoyance I have with the 9700X is that it's, like, super low power out of the box. Which I guess is probably how most people would use it anyway, but yeah, I'm personally not a fan. So that is a 13936, and we're also going to run PyPrime, which is like, the problem with PyPrime is that, like, it scores better if you disable SMT. It scores better, like, there's, like, a bunch of optimizations for this one, so, like, actually, I think I have it pinned to a specific core. I hope I do. I don't. Yeah, that, like, but, okay, you know what, we'll just use the default settings. That's my like, that's the problem I have with this one, is, like, there are a bunch of I mean, I also have it set to real time, but basically there's a bunch of optimizations for this one that affect the performance quite significantly, but those optimizations aren't very realistic, and if you don't know about them, then, like, you're going to run this program and it's going to give you numbers that are basically wrong. Which is one of my personal main issues with, like, when it comes to competitive benchmarking, all of the weird software tweaks to me are just obnoxious, because it's like, I don't care about fixing weird software issues. I just want a faster graphics card. Right? So, yeah. And unfortunately, memory benchmarks are basically the definition of weird software bugs. So, and I'm running the 4 billion variant because the 2 billion variant is, like, it's also a very good memory test from, like, a latency perspective. Like, PyPrime is super latency biased out of the various memory benchmarks that exist. But the 2 billion variant is, like, even less consistent because it's so short. So we're going to run this 3 times because it doesn't take that long. Technically, I should have probably run TimeSpy 3 times as well, but nah. Oh, and another thing with PyPrime is, like, if you run it at different CPU frequencies, you get different results, and yeah, so, like, if you run, so one of the issues is, like, if you run PyPrime on, say, like, a really low clocked Ryzen CPU, and then compare it to results from a really high clocked CPU, you don't get comparable numbers, even if the memory performance is technically about the same. Like, it makes sense if you think about it, right? Because this, unlike the IDA latency test, this is actually trying to do a calculation that just so happens to be very awkward in how it accesses the memory. So it's like, that makes it a latency test. But because it's actually running a calculation on the CPU, the next memory request can't start until whatever the CPU is currently processing is processed. So CPU frequency does slightly affect PyPrime times. And so even if you have, like, the exact same memory settings on 2 different systems, if one CPU is clocked slightly higher, the one with the slightly higher clocked CPU is going to be getting better results, right? Which, yeah, like, technically IDA also has that problem, but it, like, mostly avoids it by just not doing anything useful with the memory requests that it sends. But the trade-off to that is it's also a memory latency test that's so low load that, like, one of the reasons why disabling power down mode helps IDA latency is because the IDA latency test is so low intensity that the memory controller literally goes to sleep if you have power down mode enabled, which doesn't happen in real applications. But anyway, so I guess we'll like start off with just checking how far we can push 2-to-1 mode. I imagine it'll probably just hit a brick wall at 7200, and I don't have like a fix for that. Like I think probably if you spend a bunch of time fine-tuning the terminations, it might be possible to push higher, but yeah, I don't know. I haven't like I've more or less decided to avoid spending a bunch of time dealing with that because it is a pain and it takes forever. So, and the reason I'm loosening out the timings right now is obviously if we're going from 6400 to 6800, we need to run looser timings because I am not going to be raising voltages just yet. So we're going to go to 126 for TRAS because it doesn't affect performance. Right now, we're just going to check what we can boot. We're not going to actually run any benchmarks. I mean, once we get to 7200, I'll like dial in some of the other timings and then see well, yeah, well, if it boots 7200, we'll check what the performance is like because I'm just kind of idly I'm somewhat wondering how it'll compare to like a 1-to-1 mode setup. But if it doesn't boot at 7200, we're not benchmarking 2-to-1 mode. Because at anything like 7200 is going to be bad, but at least it might have like a small chance that it's not completely horrendous. But anything less than 7200, and I think you like it's just 1-to-1 mode is just going to be way better. So there's no reason. And actually, even 7200 1-to-1 mode should be way, way better. But yeah, like if it could run 7600, then it might be viable. If you have like a CPU that has a very weak 1-to-1 mode, or if you just want to like run low SoC voltage, because obviously if you're in 2-to-1 mode, you can get away with very low SoC voltages. But yeah, if it's not going to make 7600, then I don't see a point. Okay, so 7200 boots. That's not too surprising. That usually works with dual rank on Ryzen, in my experience. I mean, I haven't stress tested it, but it usually boots, because again, like I mentioned, I don't really... Like, 7200 2-to-1 mode is unfortunately just kind of not, from a performance perspective, viable compared to 1-to-1 mode. So, yeah, that's why I've never really bothered, like, stress testing it. Yeah, anyway, let's see if 7400 works. Honestly, if this boots 7400, I'll be actually very impressed, because this is just a 6-layer PCB motherboard, and it's a 4-dimmer. Because I've not... Then again, it is 2x48, so that should help. Because I've messed around with, like, trying 2-to-1 mode on 2x32, and that does not... Yeah, it does that. So... So, okay, no differences there. So I guess I should have just tried seeing how far I can push performance on the 7200 setup. Yeah, well, we'll just... I'm not sure... I guess we'll find out if this motherboard's auto recovery is any good. Okay, I think it is, because we're sitting on that 15 for an awfully long time. So I think it's actually in, like, default settings right now. That's always, like... So that's one thing I dislike with the AMD, like, memory overclocking, is that at least if you buy a high-end enough Intel motherboard, you have safe boot on it. But on AMD motherboards, you're kind of just stuck hoping that the auto recovery works, and when it doesn't, you're just stuck with clear CMOS. So, though the auto recovery might have just wiped all the settings, so may as well be like a clear CMOS anyway. But we'll see, I guess. Oh man, this is taking forever. I fully expect this video to take like an hour. I don't really hope... I kind of hope it'll be shorter than that, but... Yeah, I really should have just benchmarked 7200 before trying 7400. The worst thing is that clear CMOS on this motherboard also takes forever to post, so... I'm pretty sure this is just the auto recovery doing its thing. So, like, I don't actually have a better alternative than to just sit here and wait for it to boot up. At least you can, like, skip ahead in the video. Or you can speed up the video. I can't speed up the motherboard's post time. Please? I always get excited at the 99 code, because at least when it isn't messed up, like 99 is the, like, right before it actually does post, but... Oh? Maybe? I think... Yay! We're in the BIOS. It just hasn't showed up on screen yet. Yeah, so boot failure detected. Let's just enter the BIOS. All the settings are still here. So with any luck, I should be able to just set it to 7200 and it's just going to work. I do want to, since we are in 2-to-1 mode, I am going to push, well, so with 2-to-1 mode, if you're at high enough frequencies, like if you're at like 7600, you can actually synchronize with 1900, right? That actually synchronizes. If you're at 7800, you can sync with 1950. And if you're at 8000, you can sync with 2000, and then like 8400 synchronizes to 2100. So that's all cool. But if we're at 7200, it'll synchronize to like 1600, which is... Oh, wait, no, it'll synchronize to 1800, which is bad. So we're not going to do that. And instead, we're going to go to 2166. Because I don't know if the CPU can run 2200. So this is like, I consider like 2166 the sort of the lazy safe option for FCLK. And we're going to go with 1.1 volts on the SoC voltage, because sometimes the FCLK does need a bit more SoC voltage. If we were at like 2000, the SoC voltage could probably just be a single volt. It could just be like 1. But yeah, with 2166, I'm not so sure about that actually working. So 7200. Is there anything else I want to change now? We can leave the rest of it on auto for now. We're going to go 36. Give me a second. I need a calculator. Because I don't usually bother tuning memory at 7200. So, let's see. So for 6400, I would basically expect 38 to work. So that's what? 38 divided by 64 times 72. Damn it. Okay, so that's 42.75. Okay, so 42 should work. Actually, we can probably run lower TRP than that. TRC 80? Seems maybe a bit low. And you know what? I'll just put 84 in there. Okay, this can be as low as it goes. We'll just do plus. Oops. So the thing is, The reason why I'm so incredibly bad at navigating the BIOS is that I can barely reach the keyboard from my current seating position. So that makes things difficult. Right, so this is MDI, right? So 600, RTP 12, 12, 8, 32, 16, 4, 8, 1. Oh, and we're on dual rank, so we're actually gonna set these as well. Is that gonna work? I seem to remember like the right to rights being not. Yeah, like those usually need to be looser, so we're gonna set those a bit looser. This should be good. And the reason I'm not bothering to set these two timings is that those don't do anything, so there's no reason to set them. Yeah, it should be fine. I'm a bit iffy on the TRCD being as low as it is. And it really should be fine. I mean, what's the worst that can happen? Like, TRCD, it'll probably... If the TRCD is a tad too low, it'll probably boot and then just not be very stable. So that's not really the end of the world. Cast latency's at 32.6, right? Yeah, it should be. Okay, so that booted right up. So I'm not completely clueless. Even though like 2x48 is a setup that I've basically not run at all. Because, yeah, if I remember correctly, I only have one other 2x48 kit. So here we are. We're going to start with TimeSpy, though also we're going to check Zen timings that everything applied the way I hope it did. Yeah, so 3600, 2166, 1800. Yep, everything looks as it should be. Go away, Steam. So the score to beat is 13,936 points. I'm kind of hoping for just under 15k, but I'm not sure. Oh, we're like way over that. 15 and a half almost. Yeah, so that's a decent boost. That's like 10% right there, isn't it? Yeah, it is like 10%. So, might not be completely horrible from a performance perspective. 15.4k. And now let's run PyPrime. I think PyPrime is going to be like... TimeSpy, unfortunately, is kind of a memory bandwidth test, so... like the one-to-one mode... one-to-one mode settings against it, I'm not sure how that's going to work out. PyPrime, I think, is going to be a lot more revealing in that in like the latency department. Okay, so we dropped by 5 seconds, pretty much. Actually, yeah, 4.5. Because previously it was doing like 23.2-ish. Now it's doing 18.7. It's kind of nice when you're making like changes to the memory that are so big that there's no doubt about whether or not it's faster. It's like annoying when you're like trying to test one memory timing at a time, is that a lot of memory timings make so small differences to performance that it's just like it barely shows up in any benchmarks. Even something as crazy sensitive as pi prime, you end up having to run it like 10 times before you can be certain that like it was actually the timing and not the like random variance of software being software. So that's an 18.87. One more time. Oh, this one's going to be slow. Oh well. 18.85. Oh, so that was actually less of a slowdown than I thought it would be. Man, this pen sucks. Why didn't I just take one of the damn Sharpies? Oh, because I keep grabbing light-colored ones. There we go, that's a black. Okay, so that's a, like, sloppy 7200 setup. And this is one of the reasons why it's, like, Expo to me is, like, kind of useless, because I can see this might even be stable. One thing I'm wondering is maybe the TRC could be a touch lower, not much lower, because 24 gigabit MDI is a lot weaker in the TRC department than 16 gigabit ADI is. TRP might do 36. Definitely, if we shoved more voltage into this, we could run lower cast latency. Like 7200 CL32 would be relatively easy to do. But yeah, like at this point, it's not like at this point, it's not really gonna get much faster with any kind of adjustments I make to this. Um, but yeah, so like you know, like just some what I would basically consider a very sloppy set of timings is like, oh yeah, that's already like 10% faster than the Expo profile. So let's see what we can do in one-to-one mode. I'm kind of thinking of pushing it to 6000 CL26 because that's kind of the new hotness. At least as far as like Expo settings go. Um, Obviously, it gets completely like destroyed by manual tuned timings, even if you're not at CL26. But actually, before we do that, I think I want to know what CL32 would need. Because we're probably going to end up at some completely ludicrous voltage anyway when we go for CL26 at 6000. So am I doing VDDIO, VDD, VDD? Yeah. So let's see, 32. I don't really see anything else I want to change right now. I mean, there is the, like, if we go through the, we're going to do one other tweak. We'll consider this like advanced tuning, if you will. So we'll set this back to auto. And then we're going to go AMD overclocking, DDR options, timing configuration. Oh no. Wait, so should be enabled right now. Okay, so it is already enabled. SPD timings, TRCD, WR. Hell. Okay, well, 16 is 10, isn't it? Because it's in hex. We're programmer. I'm bringing the calculator back. It's the wrong calculator. Okay. Let's go to, nope. There. So right now it's a 27, which is 39. Okay, that makes sense. I want 16. That's 10. Okay, so I did remember correctly. So TRCDWR 10, TRCDRD. Oh, they're right next to each other. Man, wait. This is gonna overwrite. I really hope this works the way I think it works, and it's gonna overwrite the settings. Imagine if Gigabyte, like, actually, I don't know, moved the TRC-DWR setting into where it's supposed to be. Anyway, for TRC-DRD, we still want 42. So that is 2A. And that should be good, right? Because we didn't... Yeah. Well, I think because they're not seeing anything else change, it should work. Hopefully we'll get a 42 and 16. You know, that might actually make more of a difference than the cast latency adjustment. That's how little cast latency matters. See, my main concern right now is that it's trying to boot the expo timings at 7200, but the fact that it trained, evidently it wasn't trying to do that, because actually CL34 would probably work. With how much VDD I just shoved into this, it would probably work. I guess we'll find out. And like TRP39 would not be a problem. At least not right now. I don't know if it would actually pass stress tests, because actually, like, the funny thing with TRP is, like, I think to myself with, like, ADI, it's like, oh, you can't really set TRP much below cast latency, but then it's like, that's also in the context of me shoving, you know, crazy voltages into ADI and running cast latencies at, like, super duper low. So, yeah, anyway, let's see if that worked. Oh, see this, oh man. It did not work. Gigabyte. Yep, Gigabyte BIOS things. 6400. Yeah, okay. Well, we got our voltage, so I guess we're going to be doing all of the timings in hex. I hate this so much. See, it's literally like, if it was that you could just use that and the main menu at the same time, I wouldn't mind so much. But as it is, this is just stupid. Actually, I wonder if I could just switch everything to auto in the AMD overclocking menu, and then the main menu would override those settings. I don't know what the, like, logic flow of Gigabyte's BIOS is. I didn't mash the delete button hard enough, and somebody's going to be like, oh, Buildzoid, there's like a command you can use. Yes, I'm aware. I like mashing the delete button. Gives me something to do while waiting for the system to boot. Hey, there we go. Okay, so I am thinking that it will probably work the way I want it to work if I just do... auto... Oh. Auto... Wait, no. We want TRCD. Because I'm thinking if I just set everything in this menu to auto, the other menu is going to override it. Is my thought process. At least, yeah, that's what I'm hoping for. Let's see if I'm right about that. Well, it posted, so that's a good sign. Because, like, my thought process is, like, before I went into that menu, it was probably all set to auto anyway, right? Like, that's the point of auto, is, like, the default motherboard setting is auto. Um, and yeah, I was right, 7200. Okay, so that's actually not that bad. You just have to manually set everything to auto, and then 32, 16, 42, 38, 126, 84, 8, 12, 32, 416, 48, 600, 8, 30, 12, 16. Cast write latency is always just set to cast latency -2. 16, 4, 1, 8, 8, 1, 10, 10. Good. So let's see what TimeSpice thinks about this. I'll be surprised if it goes up by more than like 200 points. Right, so previously we got a 15.4 thousand. Hello? Is it really unstable right now? No, it's just being stupid. Actually, it might be really unstable, but like with Windows 11, um, I would actually be leaning towards just blaming the OS. It's kind of funny to me how like Windows File Explorer has gotten progressively less functional over the years. Like it definitely peaked on Windows 7. Okay, so this is running really slow for some reason. Yeah. So that's worse. Okay, let's see if what PyPrime thinks about it. I wonder if maybe me messing with the AMD menu didn't change some like training parameters. Well, the PHY-RDLs are mismatched, but that's kind of like that should have been the case in both scenarios, so I don't know why that would be. I mean, like, why? I don't think that's responsible for the TimeSpy score being so bad. Because, yeah, it looks like PyPrime. Well, I don't know. Well, I'll just wait. It's only 18, going to be 18 seconds anyway. So, no. So, PyPrime is faster. Yeah, 18.34. Yeah, so TimeSpy just isn't sensitive enough. Like, 200 points down in TimeSpy is very much margin of error. Because, yeah, I mean, half a second in PyPrime is also kind of within margin of error, but less so. Yeah, so this is the scenario where, like, if I wanted to verify if this is actually faster, I would run like 10 PyPrime like 10 times. Then I would go back to the CL36 setup and run PyPrime 10 times again, and then make up my mind after that, because freaking memory benchmarks and consistency just do not agree with each other. Um, and that's one of the other issues with IDA is like, yeah, it's also suffers from the like, you just have to rerun it a bunch of times before you get the best score. Um, yeah, so the previous three with the like CL36 setup was 18.85, 18.68, and 18.87. Whereas now we're getting 18.36, 18.34, and 18.434. So this is definitely very, very slightly faster in PyPrime, which also explains why TimeSpy basically can't tell a difference, because, yeah, TimeSpy is not that sensitive. Especially not to latency, which is basically the only two things we changed right now. We didn't really boost bandwidth because, like, Ryzen CPUs don't have any, especially single CCD Ryzen CPUs don't have any write bandwidth to begin with, so so like that's gonna change anything. But you know, just for fun, let's run it again and see if this time it goes up. It might go down again. Time spy in my experience is like plus minus maybe like 300, 400 points. That's one of the downsides with it. I think 3D Mark 11 physics test is, nah, that one's also kind of all over the place. Like, I can't think of a memory benchmark where I'm like happy with how consistent it is. Like off the top of my head, I can't name one where it's like, nah, you need to rerun it like a bunch of times. Yeah, so this time it's faster, I think, than last time. I mean, I don't think it's much like the best score yet, but it's marginally faster. So maybe Time Spy is upset about something. Because it is heavier than Pi Prime. That is one downside. Do I have any stress tests installed on this OS? I mean, there's LinPack. There's probably Prime... No, I don't see Prime 95. Well, that's unfortunate. Yeah, LinPack is not great on this. Okay. So it might be slightly unstable right now, is my theory. Or Time Spy is just being Time Spy and we need to rerun it like 5 times before we get a good score. Or maybe the previous run that got, like, what was it, 15.4 thousand? Maybe that run was just really lucky, right? So that's always just kind of like the fun part of memory benchmarking. It's like, was my previous result just extremely lucky, or are my current results actually that bad? And that's why you have to run your memory benchmarks over and over and over and over again. That's also why, like, as much memory overclocking as I do not like memory overclocking. As far as I'm concerned, it is the worst kind of overclocking. And the only reason it's worth it is because Expo and XMP are so incredibly bad out of the box. If it weren't for the fact that default memory settings are atrocious from a performance perspective, I would not like want to touch memory overclocking with a 10-foot pole. Yeah. Anyway, so that's CL32. Actually, I wonder if 1.65 volts would maybe be enough for CL30. Though, this is MDI, so that's probably a big ask. Anyway, let's switch to 1-to-1 mode and see what we can do there. Now, fun fact, 1-to-1 mode, DDR5-6000 runs your UCLK at 3 gigahertz. Technically, there is a 3 gigahertz FCLK ratio. It is not runnable. It's not stable at all. Don't even try. And because of that, the Infinity Fabric in 1-to-1 mode is never synchronized with the memory controller, okay? This is just a thing that I get annoyed about because I've seen it a bunch of times on the internet where people are like, oh, 1-to-1 mode is synchronized. No, it freaking isn't. But there is a very slight optimization of the like buffers because you have to buffer the data. If you're going from a, memory controller running at 3 gigahertz to a Infinity Fabric running at 2 gigahertz, there needs to be some buffers in between. And those buffers are optimized for a 3-to-2 ratio, as in you get slightly better latency at 3-to-2. But that optimization is so minor that as soon as you hit like 2100 megahertz, it's just faster than running 2 gigahertz FCLK. So if you're in 1-to-1 mode and you're at like DDR5-6000, your goal is to run like 2100, 2133, 2166, or even 2200. Many CPUs will not be able to run 2200, but at 6000, I think most CPUs should be able to run like 2133. That really shouldn't be a problem. Anyway, we're going to go up to 1.2 volts on the SoC voltage now because I don't actually know how good the CPU's memory controller is, but even potatoes can usually run 6000 with 1.2 volts. So, yeah. That's where we're going to go with. And now for the memory timings. So we're going to go 26, 32. Yeah, it makes sense to me. We're going to leave TRAS alone. 60. That might be a touch low. Yeah, because if it worked at 60, then I could have been running 72 at 7200. 5, 4. Actually, that's unnecessarily high. RTP. This should be able to do 8 now. 16, 4, 8, 8, 8. 8, 8, 8. Actually, these can go a bit lower now. So now we just need to do the TRCD and TRP. And actually, now that we're in 1-to-1 mode, we're also going to do our nitro settings. So this actually provides like a really big performance boost. Yeah, this is very substantial. And now the one issue is that these do vary with like CPU quality. So not every CPU is going to be able to do 120 at 6000, but I think at 6000 it should be relatively easy to run 120. The bigger concern is if you're at like 6200 or 6400, then it gets progressively harder and harder to run low nitro timings. Though if you're in 2-to-1 mode, it actually makes the nitro timings a bit easier to run, because I think these are tied to UCLK. Because these are an internal, like it says down there, like I think receive timing between memory controller and PHY. So yeah, this should be running at the... Well, I'm not sure if it would be running at UCLK or like it's like tied to the UCLK somehow. Because, like, funnily enough, in 2-to-1 mode, even at DDR5-8000, I don't think I've had a single CPU that can't run 131. So for DDR5-8000, I usually use that. But in 1-to-1 mode, I have had chips where, like, 120 or 131, like 131 or 13... Actually, 131 and I think 121 sometimes don't work at 6400, where I have CPUs that do run that. So, yeah, that's something to watch out for with these, is these do vary by, like, CPU silicon quality, but I think at 6000 the clocks should be low enough that 120 should be relatively safe. Though I guess we might find out that, like, because I don't think I've ever actually pushed this CPU in 1-to-1 mode, so I might be in for a surprise here. Anyway, what is 36? In magic computer numbers. 24. Is that it? Is that really it? This is... It seems a bit too easy. I'm just going to bump this to 66. The funny thing is, like, fine-tuning the TRC that much, like, if we could drop it to, like, 32, that would actually be significant for performance. But I can tell you for a fact that this is going to crash on 24 gigabit MDI, so there's no way in hell that's going to run. I think 48, maybe, but I'm not sure. So yeah, we're just going to go with 66 for now. I don't really feel like dealing with a bunch of random instability. And that should do 6026. And then we're going to, like, see how low I can push the voltage before it stops working. I think that's what we're going to end the video on. Oh, and we don't even have to worry about the PHY RDLs, because for the PHY RDLs, there's the, where was it? DDR PMU training. Yeah. So if you actually read the description, DDR default is 3 for higher frequencies than, like, 6400 or higher. Or wait, is it always default is 3? I'm pretty sure this only starts being an issue once you're at 6400 or higher. Well, we'll leave it on auto for now, and if we get mismatched PHY RDLs, we'll fix it. Now we can put the calculator away again. Did I remember to lower the memory frequency? Because I've done that once before, where I switched to one-to-one mode and left the memory frequency at 7200. Or 8000. Actually, I think it was 8000. And then I was very surprised when the system wouldn't post. It's like, but why? We're at 6000. Evidently, I didn't. Let's check Zen timings that I didn't punching in anything stupid. Also, I want to check the PHY RDLs. 36, 16, no, 26, 16, 36, 32, 126, 66, 8, 8, 32, 416, 48, 512, 8, 6. What? Oh, I guess that got caught in the... Ah! Okay. Well, luckily this doesn't really affect performance very much, so that doesn't really matter, but whatever. Yeah, so PHY RDLs are matched right now, so that's cool. We don't have to worry about that issue. Let's start with TimeSpy. Now, funnily enough, TimeSpy is kind of bandwidth biased, so this might be slower than the 7200 setup, which would be weird. I mean, it wouldn't be weird. And actually, that 7200 setup, if you tuned the nitro timings, might be... like, that might not suck that much, even though it's in 2-to-1 mode. And there is a very, very slight, like, performance per clock increase from being dual rank. But with DDR5, like, on DDR4, dual rank is just huge for performance. But because DDR5 has just such a high number of bank groups, dual rank doesn't really help anywhere near as much as it did on DDR4. And it also helps that you have, like, the sub channels on the memory, because the whole benefit of dual rank is that you can run more, like, you can do certain memory operations in parallel, but like DDR5 by design is way more parallel than DDR4 ever was. So yeah, also this is slower. I mean, not much slower, but it is slower. Yeah, we just lost a couple points. Goes to show how well, okay, now let's see Pi Prime, because Pi Prime is the one where I'm like, okay, this is actually a latency test, whereas this is leaning more towards memory bandwidth, because this is a AVX based calculation. And very, like, well, not very multi-threaded. This generally scales only up to like 16-ish threads, but yeah, it's pretty multi-threaded, whereas Pi Prime is entirely single-threaded. And so doesn't really have like a lot, like it doesn't, yeah, move a lot of data around. But the data, like, oh, and yeah, you can already see it. So yeah, Pi Prime, very much latency biased. Yeah, like that 2-to-1 mode setup isn't even close. Actually, it's closer than I thought it would be. But yeah, this is like... So it depends on what kind of workload you're running, I guess. But it, like, that's always the case, isn't it? And it's not like I'm nerfing the FCLK right now, right? Like, we have the same FCLK for both setups, so it's not like the actual, like, like, the bandwidth from the I/O die to the CPU hasn't changed. The only thing that's changed is the memory bandwidth, which is kind of wacky to think about, because it's like, yeah, but, like, how can, like, TimeSpy, you know, prefer 7200 when the internal, like the I/O die to CPU bandwidth, it hasn't changed, and the memory bandwidth, even at 6000, is so much higher than the bandwidth of the FCLK. It's like, it doesn't really make a ton of sense, but it's just one of those things that, like, Ryzen CPUs do, where, like, 2-to-1 mode is, for things that are bandwidth biased, generally the way to go. But yeah, like, so TimeSpy's CPU test is not actually very representative of, like, gaming performance. I should point that out, because it's closer in terms of how it, like, in terms of how it scales with memory bandwidth, it's closer to something like YCruncher and LinPack than it is to games. Anyway, so now we've got an 18.086. Actually, having 3D Mark open in the background probably isn't helping. But yeah, so this is another like 0.4-ish seconds faster than the CL32 7200 setup. Now, obviously, in one-to-one mode, we still have room, right, to go up, because 6,000, if you have an absolute potato of a CPU, you might get stuck at 6,000. But pretty much any chip, in my experience, will be able to run like 6,200 without too much trouble. And even if we run 6,200 at a lower, like a looser cast latency, it's not, like, it should, like, and I think this might be just due to how, like, I have a theory that like AMD's actual memory controller itself is not that good at being a memory controller, as in like efficiently managing the data in the memory. So even if we go to like 6,200 should actually give us a performance advantage. Even if we're running like 28, and we are gonna have to loosen out TRC DRD. I think. Well, okay. I mean, not maybe must, but I'm pretty sure that it might get upset with us. So we're gonna just go to, okay. Well, 25 is after 24, so we're gonna go with that. So that'll be 37, 32. Actually, I'm kind of iffy on that. 512 should still work at 6,200. This might be cutting it a little bit close. TRDL8. Oh, and let's fix this now. Actually, now that we're in one-to-one mode, we could drop this to 4, and this to 4 as well. If we're lucky, this kit might be able to do 6,200 CL26 with reasonable voltage, but I'm not, like, I have A-die kits that need, like, 1.65 volts to do CL26 at 6,200, and M-die is generally a tad weaker in the cast latency department. That's why, like, you don't, like, I'm not aware of an M-die 6000 CL26 bin, whereas there's a bunch of 6026 bins for A-die. But even like CL28 6200 should just beat 6000 CL26. Because yeah, with Ryzen MCLK in one-to-one mode, MCLK is king. And actually, even in 2-to-1 mode, MCLK is king. But the issue is, like, when you switch to 2-to-1 mode, you're basically like losing a bunch of per clock performance. So then you need to clock the memory ridiculously high to compensate for that. Anyway, let's start with 3D Mark. This might actually pick up a little bit because of the back-to-back timing adjustments I made. Also, let's check Zen timings, because I want to know if the Phi RDLs are messed up or not. And they're not. Yeah, because we're not at 6,400 yet. That only happens at 6,400 and higher. Hello, 3D Mark. Okay. Oh, I think this will be like just faster across the board. Or not actually. Well, oh, let's see. That frame rate counter was all over the place. Though towards the end it was weak. Yeah, that is interesting. I wonder if it just derped out. Because that does sometimes happen with Time Spy. Is that like actually, I think every 3D Mark physics test does this. Like, especially Firestrike. I hate that about that bench. Like, Firestrike is my favorite 3D Mark, but the physics test in Firestrike is just like so annoying. Because I've seen it go, and admittedly, this is on CPUs that are like spitting out like over 50,000 points, but it can go up and down by like 1,000 points, which is ridiculous because that's like 2% of the score. Or, well, not the overall score, but like it can change by like 2% run to run. So you'll like run it and you'll get like a really good GPU test and be all excited, and then physics just like runs like hot trash. Yeah, so 15.4K. So yeah, so Time Spy just evidently doesn't care much for my fine tuning of the memory system here, which yeah, that's not really that surprising. Um what does Pipe Prime think? That's not a good start. Oh, this is exactly the same as the 6020. I mean, yeah, it's like exactly the same as the 6026 setup. But that was just the first run. But yeah, so like this is one of the kind of like funny things to me with like seeing people do like memory tuning for like gaming setups is like I feel like a lot of people spend way more time on it than necessary because it's like this is easily the most memory sensitive benchmark that I use and that I'm aware of, and yet here we are. But apparently 6026 was faster, so that's interesting. How many things? Oh, I did also raise the TRCD. Yeah, I guess that makes sense. But we have like we're still in the same nitro timings. Wait a minute. No, if we were in 2-to-1 mode, this would be way slower. Yeah, no. Interesting. Yeah, so this is like very marginally slower, I guess. Probably because of the TR. Well, I also raised TRP, so yeah, that kind of makes sense. Though this would probably work with a lot less voltage, so the thing now I'm wondering is maybe we can do CL26 at 6200. That would be pretty cool. And then we can run Pipe Prime again and watch it maybe, score like 0.05 of a second better. Um, and especially like if you have an X3D CPU, like I'm very tempted to say that if you have an X3D chip, you should just do like a very like basic 6000 setup and just call it a day because anything more than that and it's just like I don't know why you're bothering. Um, let's see. 26 at 1.65. Now, one issue I can see is that if we don't have enough VDD, we're gonna be stuck on the whole like really slow auto recovery process again. So maybe I should have raised the voltage first and then like bumped up the VDD voltage to like 1.7 to basically force it to work. Um, and then only after like having performance data start lowering the voltage, right? Because we can just end the video once it doesn't boot. But apparently it does boot, so that's cool. Um, so maybe it would even do TRCD 36 at 6200 to be very marginally faster. We're not even going to bother with Time Spy this time. It's just a complete waste of effort. It, like, actually doesn't care. So we're just going to go straight to pi prime, because best benchmark. There's other tests, like, I guess you could try messing with, like, clam bench, Y-cruncher if you want to test memory bandwidth, super pi if you want to hate your operating system. That's this benchmark over here. This one also takes forever to run. Yeah, and then there's like Y-cruncher. This is really hot as well. Like, this really hammers the CPU. Also, it's super, like, bound to FCLK performance. Well, that's a good start. Hey, it's about the same as the 6000 setup. It is like 0.05 faster. Yep, that's still 0.05 because the 6026 setup scored a 17.948, 18.086, and a 17.939. I guess you could call it like 0.07 faster then. But yeah, on a run that takes, almost 18 seconds, that's really not much of an improvement. Looks good in screenshots though, and you can go like, oh yeah, I have 96 gigs of RAM at CL26. Oh, this one's fast. Okay, so well, I guess we could call it 0.1. But I'd still consider this mostly like screenshot um, tuning rather than like. I mean, it affects the benchmarks, as you can clearly. At least if you find a benchmark that's sensitive enough, it affects it. But yeah, as far as like, oh, you'll really notice the difference in day-to-day use between CL26 and CL28, nah. Or even like CL30. But I'm honestly kind of surprised that this is working without complaining. So now I'm wondering how low can we put the push the voltage before this completely stops booting, which is not the same as being stable, right? Like, it can be, well, cast latency tends to be a pretty clean breaking point. Unlike TRCD, like TRCD, you can quite easily set it like 2 ticks too low and it'll still kind of run. But yeah, I'm kind of wondering how low can we push the voltage, because I'm kind of surprised that, I mean, am I? I don't know. I don't think I tried CL26 at 6200 on the other 2x48 gig kit that I have. So let's try if it'll boot at 1.625. And then we're going to try 1.6. And then 1.58. If it boots at like 1.55, I'll be impressed. Like, very impressed. Because I do have kits that like will not do CL26 under 1.6 volts. Okay, so that boots right up. I mean, I guess the other way you could look at the like CL28 versus CL26 test that I just did is that like raising the memory clock by 200 megatransfers didn't really make that much of a difference either. And you, instead of like trying to lower the cast latency, you could have just stayed at 6000 CL26 and tried to lower the voltage. Oh, I run an M.2 SSD, so I can't just pull the wire. See, that's why I like the SATA drives, because when you want to just not go into the OS, you can just unplug the cable and you're good. Whereas with the M.2 drives, you need to like reach into the motherboard and pull it out, and it's just like, ugh. I guess I could technically disable it though, in the boot options, maybe. Oh, we'll see. Anyway, so 1.625 boots. Does 1.6 boot? Usually when you set the voltage too low for the cast latency, it crashes pretty quickly. Like, I think you get a 0.5 or a C5 pretty fast if the voltage isn't high enough to boot. Because, like, if your cast latency, if you don't have enough voltage for your cast latency, like, your memory is basically not usable. As every single read operation is dependent on the cast latency. So let's try 1.58. Man, this is still booting. I mean, at this point, I'm kind of suspicious of how stable it is, but I'm kind of impressed. Yeah, we'll just go straight to 1.55. I suspect this is the point where it will stop, right? Because, like, this isn't, like, the spec on this isn't anything, like, super special. It's 6400 CL32 at 1.4 volts. Like, that's not, like, a, you know, bad spec, but it's just, like, that's pretty typical Hynix things right there. So, like, I wouldn't expect it to be able to do CL26 at, like, 1.5? How is it still boot? Like 1.55, that is low. That is like surprisingly low, especially considering it's 24 gigabit M die. Now I'm wondering if it'll do like, so maybe at like 6,000 it might do CL26 at even like reasonable voltages. This got to stop working now, right? If this boots, we're going into Windows and we're going to try to run something. Y cruncher. Yeah, we'll quickly hit it with a Y cruncher and see, like, because there's no way. Like, this is way too low for CL26. Oh, there we go, C5. Okay, so, you know, at 1.58, it would probably work. Or even like 1.56, yeah. So it probably, like, for full stability, it probably doesn't need anything more than like 1. Yeah, it shouldn't need more than like 1.6. Because just the fact that it can boot at 1.55, like, you don't, like, TRCD, you can go way lower than is stable. But cast latency, usually, you don't get that much, like, you don't get, like, a big zone of instability. or like a big range of instability. So yeah, so that's cool. So I guess, I mean, I ultimately do want to try push this kit back up to like 6400 and well, well, if it works at 1.55, then it might do like 6400 CL26 at 1.65, right? So, yeah, so I do like, well, the thing is, I mainly want to stress test this memory kit with a actual like 9950X because I think stress testing a kit like this with a 9700X is a bit silly, right? Because like the 9700X just doesn't have that much memory bandwidth, and I am testing in 1-to-1 mode, so the main issue with my 9950X is that its 2-to-1 mode is extremely bad, but that doesn't matter if we're just testing 1-to-1 mode. So, yeah. Anyway, so that is the Kingbank 2x48GB 6400 CL32 kit. And yeah, like my eventual plan is to try like set it up at like 6400 with the 9950X. But so far I guess I'm kind of impressed. The thing is I've not really tested that much 2x48, so I don't really have expectations for this, but yeah, I didn't think it would like work at CL26 so easily. And honestly, maybe at 6000 it would actually yeah, it'll probably do 6026 at like a reasonable voltage. Um So I don't know, maybe if people are more interested in that, then I could do that instead of like trying to push it all the way to 6400. Um, but like like I kind of like on one hand, I like how easy 6000 is to tune, right? Like for a daily setup, it is very convenient to just smash some better sub timings onto a 6000 setup and call it a day. But from like an overclocking perspective, it's very boring. So I don't know. Like a low, like a, it wouldn't really be low voltage, but like a medium voltage 6000 CL26 setup with these sticks, if people would find that interesting. I don't see why I couldn't do that. But I just think it would be a bit boring, and at the same time, yeah, like I don't know. So leave your thoughts in the comments below, I guess. And that's it. So, big thank you to Kingbank for sending over these memory sticks. They will be in a, like, I will definitely do some setup that's like fully stress tested with them. It's just like I want to go back to messing with the 9070 and doing like GPU stuff because, like I mentioned during this video, I like as much RAM overclocking as I do. I don't actually enjoy overclocking RAM. Um, at least not like stress testing it. Okay, like honestly, like taking a kit, messing around with it a bit. Okay, that's fun. That's cool. But sitting there waiting for stress tests to crash, not fun. Especially because it like occupies way too much physical space. It's the main issue with it. Um, but anyway, so yeah, big thank you to Kingbank for the memory. If you found this somewhat interesting or useful, I guess like the video, subscribe, share the video. What else is there? Oh, right. If you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. And that's it. So thanks for watching and goodbye.